the combinations of power of lens and the difference, to find the difference between the concave and convex lens. Okay, and also we'll come to the next point, that is the Cartesian sign. Okay, Cartesian sign convection, and the last one is the lens formula. So these four things we discussed today. Okay, and we'll come to the end of that chapter, of this chapter. Okay, the first one is the power of combination of lens. Now, the lens are combined together. When the lens are combined together, then the power which we get by combining the lens, that power which we call it as a resultant power. Okay, when you combine the lens, and the lens can be concave lens as well as convex lens. So both the lenses are combined together, and when you combine that lens together, then the power which you get by combining that lens, that power is the resultant power, and that resultant power is equal. That resultant power is equal to the algebraic sum of individual power. Okay, so like I write it here, P equals to P1 and P2. Okay, P1 and P2. Now this P1 and P2 are the lenses. Okay, and this P is the resultant power, total power. Resultant is the total power. So this P1 considered as convex lens and P2 concave lens. Now these two lens we are combining, and the power of that lens we are combining. When you combine the power of that lens and the resultant power which you get, P, that resultant power is equal to the algebraic sum of individual power. Understood that? Algebraic sum of individual power. That means individual power of a lens you are adding, and whatever you add the power of that individual lens, that will give the resultant power. So therefore, the resultant power is equal to the algebraic sum of individual power. Okay. Now let us consider the first one, P1 as a convex lens. So convex lens, since the lens is convex and the power is taken positive, so let us consider as plus 5D, the power P1. P1 is a convex lens, okay, and the power of the convex lens is 5D. Then again you will take another lens, concave lens. Okay, concave lens, since the lens is concave, the power will become negative. So let us consider that power will be 7D. That means we are adding it. Okay, we are adding. That means we are finding the resultant power. So this resultant power, how will we get? By adding the sum of individual power. Okay, so we can say that it is equal. This resultant power is equal to the algebraic sum of individual power. So plus 5D plus and minus 7D. So plus 5D minus 7D, sign will remain minus because this is greater, so minus 2D. You subtract it, 2D. So the resultant power is coming as minus 2D. Okay, so this resultant power, how we are getting? We are getting by adding the algebraic sum of individual power. Okay, now the resultant power we are getting minus 2D. So the combination of the convex lens and the concave lens, they behave as a concave lens. Though the two lenses are there, convex lens as well as concave lens, but when you combine that, the resultant power we are getting as minus 2D. Okay, so therefore the resultant power will behave as a concave lens. Since the concave lens is negative, the sign is negative, okay, the power is negative. So since the resultant power is becoming here minus 2D, so therefore the combinations of the convex lens and concave lens will behave as a concave lens. Okay, so this we call it as a power of combinations of lens. So this way you find the power of combination of lens. So therefore to find the power of combinations of lens, what you have to do? You have to combine the the lens together. Okay, we have to combine. That means the lenses are kept close to each other. Okay, taking the power of that lens, the lens are kept close to each other. Okay, and after that you will find the resultant power P, and this resultant power you will find by adding the algebraic sum of the individual power. So this way you will find the power combinations of lens. Okay, so and again in the instrument, the optical instrument, okay, like microscope, okay, camera, telescope, the number of lenses are combined together. So all these optical instruments like camera are there, microscope are there, telescope are there. Okay, so here also in this optical instrument, number of lenses are combined together. Okay, number of lenses are, that means there is a combination of lenses there. Number of lenses are combined together to produce a very sharp image. Okay, when the lenses are combined together, that will increase the sharpness of the image. That will give a very sharp image. So in order to increase the sharpness of the image, number of lenses are combined together in optical instrument like microscope, telescope, and also in camera. Okay, so this is about the power of combination of lens. Next one, to find the difference between the convex and a concave lens without touching them. Okay, now how will you find how will you differentiate between the concave and convex lens without touching them? Okay. Now let us consider a book, the page of a book. Okay, you take some book. Okay, the letters which have been written in the book. You take a lens. Okay, and you bring a lens very close to the book. Okay, and when the letters of that book will become enlarged or magnified when you bring that lens nearer to the alphabets of that book, nearer to the book, I would say. Now when the alphabets of that book will increase, will become enlarged or magnified. Okay, then again, when you take the book away, when you take the lens away from that book, inverted, the letters will become inverted. So the two conditions are here. When you bring the lens closer to the book, you find the letters will become magnified, and when you take the lens away from the book, then the letters will become inverted. You know the inverted, okay, upside down. So that in that case, if this happens in a lens, then the lens is said to be as a convex lens. Okay, the lens is said to be as a convex lens. So without touching the lens, okay, you can find whether the lens is convex or a concave lens. So how to find a convex lens is, you bring a lens, you don't know the lens whether it is a concave or a convex lens, but when you bring that lens closer to the page of a book, and when that alphabets which are written on that book will become magnified or enlarged when you bring closer to it, and when you take the lens away from the book, when the letters becomes inverted, then we say that the lens is convex lens. Okay, and the next point. And when you take a lens, either you take the lens front or you take the lens behind, back. Okay, in any position, when you keep the lens in any position, either you can take it to the front or back. Okay, when the letters written on the book will become very small, diminished. Okay, when the letters which has been written in the book, they are very much diminished, very small, then the lens is said to be as a concave lens. Okay, the lens is said to be as a concave lens. So this way you can identify or you can determine whether the given lens is a concave or a convex lens.